Hello everyone. Today I'm going to go over a medium question that I just solved about 30 minutes ago by myself. This one's called clone a list with a random pointer. So it's pretty simple to clone a binary tree with a random pointer if you've solved that one. Essentially, you're given a list and you want to return a copy of it. It's also similar to clone graph, without a random pointer, which is a grind 75 question. As you can see, not with a random pointer, but just clone graph. So the idea is that you want to decopy the list that has exactly n nodes. And instead of having the original node, you're going to point to a copy node. And the way you do that is with their API here. And it's going to make more sense once I start doing it. But yeah, and then you just want to return a copy. But the only thing you want to make sure is you don't return the original list itself, or else you will get an error. So again, if you've solved the actual clone graph problem, you'll notice that I did it recursively, so we're going to take the same approach here. So let's define our recursive function. Let's pass in our node, and we'll return it at the end. And simply, we want to define our base cases. So if we're at a none node, which means we've reached the end of the linked list, then we'll just return none. Python uses none, Java uses null, same thing. And if that's not the case, then we want to simply check if the current node is already in our dictionary. So let's define a dictionary. This will make it actually quicker to do this and actually it's necessary because we're actually going to get the clone node from the dictionary itself as the value and the original as the key. So if our current node, not the value, the head itself is in our dictionary, then again, we can just return self.dhead, right? Because self.dheads, the value will be the actual clone itself, which we're going to define here. If this is not the case, which it's not going to be in the first turn because we didn't define anything, so let's do it now. So now we're going to make the copy. And again, we're going to use the node class here. And we're going to push in the value because we know it has a value because it's not, this conditional wasn't true. Cool. So after this, now we have to define, you have all these diagrams here. Essentially, you have a random and an X pointer. So now you need to define the random pointer, and we're going to pass in head.random because whatever the results, we're going to keep cloning until this recursive call returns a base case. And then the result of whatever that was would be the whole list up to that point. So for example, 11 to 1, for example. We're going to do the same thing with the next pointer as well, because we want to get all the nodes in the linked list. Again, another recursive call to clone as many next values as we have. And then at the end of this, we can return the original, which is going to be the copy itself, the head of the copy of the linked list. We don't want to return the linked list itself because they're asking you to return a copy. And then at the end, we can just return whatever the result of this recursive call is. I hope that makes sense, but let's run it and see. As you can see, that passes all the test cases. Again, if you were to do return head here, you're going to get a warning that says node with the label 7 was not copied, but a reference to the original one. You're returning what they gave you, which is not what they want. So again, we're returning the value of the corresponding original head in our dictionary. Let's submit this, and as you can see, it passes all test cases. And yep, I hope this was helpful, and again, just shows you the importance of solving similar questions before moving on instead of solving questions randomly. You're going to make progress a lot faster, and you're going to be able to identify patterns a lot better. So that's it for today. Thank you for watching. Take care.